Hi, my name is Percy Cargo Jr., and I'm an 8th grade science teacher at St. James High Middle School for St. James Parish Schools. I teach science using an amplified science curriculum. What I am most passionate about as an educator is always putting my students first. I believe students learn best when they feel supported, challenged, and trusted, and I work hard to build relationships to help them feel safe, taking risks in their own individual and team success, both inside and outside of the classroom. In the previous lesson and prior to the lesson, my students were asked to simply observe and analyze an image of two objects. Their only task was to identify and analyze what they noticed about thermal energy and temperature, allowing every student to enter the lesson with confidence, no matter their starting point. Although the standard originated in the 7th grade, I intentionally used the state achievement level descriptors to scaffold instruction and support my 8th graders. We began by learning how to identify total kinetic energy, then progressed to understand average kinetic energy, which required crossing over into their math subject content. Using my previous math knowledge and teaching experience, I was able to provide the appropriate needs for this lesson. I also modeled how to construct a graphical representation to show how an object can have more thermal energy, which is total kinetic energy, than average kinetic energy, which relates to temperature, helping students visually connect the concepts and ask questions if deemed necessary. From there, students constructed and analyzed their own diagrams to determine which system had higher temperature and thermal energy. I planned this lesson using state standards and achievement level descriptors with one goal in mind: preparing my students to reach proficiency, now classified as mastery. By breaking the learning down into meaningful steps, modeling the skills, and meeting students where they were, I was able to support their understanding by building their confidence. At the heart of it all, my goal is not just to teach science, but to help students believe in themselves as learners and know that they are always supported in my classroom. All right, we're gonna go through the objective for the day. John, go to the board. I want you to read the objective, and then I want you to underline the verb in the objective.
Students will construct and interpret a display of their data to
Differentiate
the relationship between thermal energy and average kinetic energy.
All right, good job. Bring it to Jules. Jules, I want you to come up and underline a circle. What are we actually going to construct or interpret? Uncircle it. All right, good job. So construct is the first verb. Interpret is the second, all right? And they say a display of data. What does construct mean? Make, all right? So we're going to take this and we're going to make it a little simpler. We're going to say make, all right? Interpret means to do what? Infer. Give me one more. And I'm going to write an arrow, and I'm going to say infer, or what? Give input, so we'll put that. All right, so you're going to look at a set of data. You're going to construct something first. So you have to make something, and then you're going to interpret it. All right? It says that to differentiate. Differentiate is a key word, so we're going to use a different color. All right? Differentiate means to do what? What does it mean to you? Say it one more time. All right, that's a root word in it. All right? Different is in it, so you're going to find the difference. The difference in what? All right, between thermal energy, all right, and average kinetic. Now, if you think back, we already looked at some of this very briefly. Today, we're going to dive deeper into it. So if you look at the title, what does it say? All right, thermal energy is not temperature. So, Caden, based on that title and based on our objective, what do you think this article might be about? And? All right, what else? You said something, you said a good point. You said thermal energy and temperature. So tell me, what does temperature relate to? All right, look at this objective. Which one of these is temperature, thermal energy or average kinetic? Average kinetic, all right, so that is related to temperature. So do you see Do you see this saying average kinetic energy? But it can because what? It's not thermal energy. It's the same. All right. Average kinetic and thermal energy are two different things. That makes sense? Average kinetic is temperature. Thermal energy is the total of the kinetic energy in the object. All right. So look at this picture. All right. Zacaden, what you see coming from that picture? Steam. All right. So that means it's probably what? It's probably hot. All right. When something is hot, Sophia, how fast do the molecules move? Very fast. All right. Now, as you see that bowl sitting on that table, is that bowl big or small? Small. So do it have a lot of molecules? No. So if I add a pot to that table, and let's say the pot was the same energy, the same amount, or the same temperature, how much thermal energy would it have than the bowl? It would have more. All right. Why? Because it got more molecules. All right. So today, that's what we're going to dive into. All right. So if you look at this picture, all right, let's interpret this picture. So later on, we have to construct one. All right. Right now, we're going to interpret one. All right. All right. Right now, tell me what you see, Zell. Mm-hmm. All right. You see less molecules in the mug than the bowl. What else you see? They're both moving the same speed. How you know that? Say it one more time.
The lines under them are the same length.
The lines under what?
The molecule.
All right, and where does that come from? Where did that, you said the lines under the molecules are the same length. How do you know, that represents that they have the same speed? What you got, John? Did it in the sim, all right? And we also had a diagram of that in a previous lesson that we taught, all right? So right now, which one would you say have the most thermokinetic energy? The bowl, why? It has more molecules, all right? And the cup will have what? Less, all right? Does that mean that they can't be the same temperature? All right, cool. I'm going to go ahead and draw my first object. Now, they're going to take a little minute, but I don't think I'm going to try to make it quick, all right? My total is what, Caden? 40. Good job. All right, so that is my what? What did I just find? Thermal energy, total kinetic energy. All right, good job. So I'm going to just put right here, I'm going to put thermal energy. All right, that's my total. Do the same thing over here. 8 plus 2 is 6 plus 4 is, and then 9 plus 7 is. All right, over here I have what? And I'm going to say that's my thermal energy. All right, so all I did so far was did what? All right, so I went a little bit out of order, but do it matter? All right, I found my thermal energy first. That's number 2. So then I got to go back and find what? The average kinetic. All right, so then what I got to do to that 40? So how many molecules I got? So 40 divided by 20 equals. So what does that number represent? Somebody said it. Who said it? Say it louder. The temperature, all right? Because I found the what, Noah? The average. Good job. So this is my temperature and my average. I'm going to put AVG, kinetic energy. Everybody cool so far? I did 1, 2, and 3. What's the last thing I got to do? Interpret the relationship. So if you look at the relationship, all right, it says the relationship between thermal energy and average kinetic. So if I had to look at those two objects, I would say that object 1 has a greater thermal energy than object 2. Although object 2 has the highest temperature because the average kinetic energy is 6 and the average kinetic energy of object 1 is 2. That is very simple, very to the point. That makes sense? Anybody confused? Anybody think they're going to need help? You think you're going to need help? I'm going to come to you first. You think you're going to need help? All right? If you need help, just make sure you raise your hand. I'm going to come to you, but I'm going to come to you first. All right? So now I'm going to go ahead and pass it out. Now remember, you don't have to use that one. I'm actually not going to leave it up there because I want to see who can be creative and do it on their own. Make sure you put your name on it. Make sure you read it, all right, because there is some good information on it. And then once you construct it, you have some questions at the bottom that you should answer. No. What you about to say?
Because it's going to end up in decimals.
What's going to end up in decimals?
The average.
That one should be fine.
Can 14 go into 8?
With this, how many this is? 16? Yeah, that's going to end up to this going to end up to decimal. You can put the decimal you want. That's fine.
Okay.
If you want to put the decimal using your calculator, you can. As long as you understand what the number represents. Most times you see temperature as a whole number. However, most times temperature have a decimal.
Hey, Dad, I could put this.
Yep. Put whatever you think. Do your best and try it as hard as you can. It don't have to be perfect. All I want you to do is do the work, then we'll discuss it after. What's up? That's cool. Which one that's for? This one? All right, cool. So then what?
That you have to divide.
Bye.
How many there is?
All right, Haley, what was your total for object 1? 88. What was the average? 3.52. So see how she used that decimal anyway? All right, don't be afraid of the decimal. The decimal still can tell you the temperature. All right. What was object 2 thermal? 24. And then what was the average? 4. All right. Based off of her numbers, which object is hotter? Object 2. All right. How do you know object 2 is hotter?
Because 4 is greater than 3.
4 is greater than 3.2. The average is related to temperature. All right. Which one has the total kinetic energy or the more thermal energy? Jamin.
Object 1.
Why?
Because it has 88.
What does that mean though?
It has more thermal energy.
It has more thermal energy. What else does that mean?
It means that it's hotter.
We just said which one was hotter. Object 2. We just said this one was hotter. You're missing one key piece to why the thermal energy is more. Think about the bowl in the mug.
Because it has more molecules.
Why does it have more molecules?
Because it's bigger.
Because it's bigger. Good job. All right. So the size of it, all right, can determine how many molecules it have. The lesson objectives were met. I could see students understanding in their diagrams, class discussions, and the ability to apply the concepts independently. Out of 15 students, 11 scored high-level proficient and 4 scored mid-level proficient. If I taught the lesson again, I would include a brief peer-to-peer component to where students had to learn and,
It's okay.
go back. It went too fast on me. Out of 15 students, 11 scored high-level proficient and 4 scored mid-level proficient. If I had taught the lesson again, I would include a brief peer-to-peer teaching component, allowing students to explain their graphical representations to one another. This would allow students to understand and promote collaboration while also giving students the ability to own their learning more. After the lesson, students applied their learning to follow-up activities and real-world examples, making connections between the classroom concepts and everyday phenomena. Also, I plan to revisit these ideas in the future lessons to ensure long-term retention and challenge students to apply their learning and understanding in more complex ways prior to the LEAP test. In closing, this lesson reflects my core philosophy as an educator, putting students first and meeting them where they are. Every decision from scaffolding to modeling to building trust was made to help students succeed and feel more confident. My goal is not just to teach science, but to help students grow academically and personally, creating a classroom where they feel supported, encouraged, and ready to take risks in their learning.